Today we're going to look at the quadratic formula. It's a little bit long, so a nice way to learn the formula is through a song. There are lots of different songs on YouTube. I just picked a fast, easy one, but if you want to learn a different genre for the quadratic formula, go for it. I know they have some raps there too if you prefer something a little bit more updated. This is sung to Pop Goes the Weasel. I'm going to sing the song for you. Got a little bit of a cold, so you'll have to excuse it. Please don't put it on YouTube. I don't want to become famous and just have people bugging me all the time. So just keep it between us. But the song goes, x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. I would sing this maybe 3 or 4 times till you have it memorized. I'm going to go ahead and switch papers and look at the formula itself, how it's written, and you can write the formula while you sing the song then. Okay, so in this formula, a, b, and c are real numbers. A does not equal 0. Otherwise, if a was equal to 0, that would mean that you would not have a quadratic. So we're looking at a quadratic up here in that form. So a is in front of the x squared term, b is in front of the x term, the linear term, and c is your constant. So the only thing you have to make sure of is that a is not equal to 0. Otherwise, you don't have a quadratic anymore. So they've given you the formula in here. And the formula for the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac. That whole numerator is all divided by 2a. And I have the song over here, so you can sing the song as you practice writing this formula. The discriminant is the expression under the radical in the quadratic formula. It does not include the radical. If there is a positive number underneath your square root, you're going to get 2 real solutions. Because when you take the opposite of b plus or minus, you'll get plus a little bit and then minus a little bit. So you'll have 2 different numerators that you're going to divide by the 2a. If you have 0 under the radical, so if the b squared minus 4ac equals 0, negative b plus 0 and negative b minus 0 are the same thing. They're both negative b. So if your discriminant is 0, then you'll have just negative b over 2a. So you'll only get 1 real solution. And if you have a negative underneath this radical, you're taking the square root of a negative. And when you have negatives in the radical, the square root, you're going to get your imaginary numbers. So this will give you 2 imaginary solutions, or no real. But it does have 2 solutions. They are just imaginary. So what is underneath that square root is the b squared minus 4ac. So we just decided if it's greater than 0, then you're going to have 2 real solutions. If it's equal to 0, then you end up with just negative b over 2a because you're adding and subtracting 0, so that doesn't change the negative b. So you'll get 1 real solution in this case. And then on this last one, you'll have, if it's negative, you'll have 2 imaginary. Which means there's no real. Let's look at some graphs of these. Each situation is displayed below. Which graph has 2 real solutions, thus a positive discriminant, and that would be A. Here's your x-axis, and notice it crosses two different places. Your solutions, another word for those solutions, are your x-intercepts. So this has two real solutions on graph A, so that's going to be what goes in that first blank. The one that has one real solution, and I didn't get real exciting because I put these in order, is graph B. It touches the x-axis, and it only has one place where it's touching. And this last one has no real solutions. There are two imaginary, but there are no real, which means it has no x-intercepts on that one. Let's go ahead and use the formula now to solve some problems. When you're solving a quadratic, if you have y equals your quadratic, you'll set it y equal to 0 because we're finding the x-intercepts. So there's no y's in these. We set them all equal to 0. However, you have to set the equation equal to 0. So on example A, I'm going to go ahead and move that 15 to the other side. My A is equal to 2. B equals 4. And C is going to be positive 15. Your discriminant is b squared minus 4ac. And so I like to square b and get in the habit of squaring this, whether b is positive or b is negative. When you square it, that's going to be positive. So I like to square it and make sure that that is positive right away. So 4 squared is 16 minus 4 times a times c. And that gives me negative 104 when I simplify that. Because what's under the square root is negative, this means I'm going to have two imaginary solutions. Let's go ahead and set this up. So x equals the opposite of b, so negative 4, plus or minus the square root of b squared minus 4ac, so that's my discriminant of negative 104, which I just found, all over 2 times a, which is 2. The perfect square that goes into negative 104 is going to be 4, so this will be negative 4 times 26, and there are no perfect squares that go into 26, and 2 times 2 is 4. Simplifying this, I'll have negative 4 plus or minus the square root of negative 4 will be 2i square root of 26, and that is all over 4. And I could simplify and divide all of those by 2. And so that will give me negative 2 plus or minus I square root of 13 over 2. Or if you want to separate it into a real part and an imaginary part, you could divide the negative 4 by 4 and get negative 1 plus or minus, and then 2 divided by 4 is going to be 1/2, so that'll be 1/2 I square root of 26. So I would be happy with either answer. On example B, again, you have to set it equal to 0. So let's move that negative 12 to the other side. And now I can list my A, B, and C. A is 1. B is negative 8. And C in this case is positive 12. You have to put it on the other side before you can determine what c is. And then b squared minus 4ac. Here's where people mess up on these. They put negative 8 squared in their calculator and they don't put the negative 8 in parentheses, and the calculator gives them negative 64. And then they've messed up the problem right from the beginning. When you square b, negative 8 times negative 8 is positive 64. So I'd like you to get in the habit of just squaring that, making sure that value here, b squared, is positive. Minus 4 times a, which is 1, times c, which is 12. So that's going to be 64 minus 48, which is going to give you 16. And since this is positive, that means we're going to have two real solutions. Let's go ahead and set up our quadratic formula. So x equals the opposite of b, so that's going to be opposite of negative 8, so that's positive 8, plus or minus the square root of our discriminant, which we found was 16, and that is all over 2 times a. So that's 8 plus or minus square root of 16 is 4, and that's over 2. So I have two solutions. My first solution is 8 plus 4. So I'm going to have 12 over 2, which is 6. And my second solution is going to be 8 minus 4, which is 4 over 2, which is 2. So my solutions on this are x, and I could have put x equals here too. X equals 6 and 2. For C, oh, this time they were nice and they have it set equal to 0 for us. If you want, you can go ahead and multiply through by a negative 1 here. You don't have to, but it does make it maybe a little bit nicer. I think I will. I like to start with my a positive. So this is going to be 3x squared. That'll be plus x and minus 2. You could have done a as negative 3, b as negative 1, and c as positive 2, or multiply both sides by negative 1. And I'm going to go ahead and do a as positive 3, b is positive 1, and c is negative 2. Either way will work out. B squared minus 4ac. When you square 1, you get 1, minus 4 times a, which is 3, times c, which is negative 2. And that's going to give you, sorry about that, got interrupted for ads. When you simplify this, that's going to give you 25. And 25 is positive, so that means that there are two real solutions. Setting up our formula, I have x equals the opposite of b plus or minus the square root of our discriminant, which is 25, all over 2 times a. So this is negative 1 plus or minus square root of 25 is 5 over 6. So we're going to get two solutions here. Negative 1 plus 5 is 4 over 6. Which reduces to 2/3. And my second solution is negative 1 minus 5, which is negative 6 over 6, which gives me negative 1. So our solutions are 2/3 and negative 1. On D, we have some nasty decimals. So let's go ahead and get rid of those. This is the hundredths place, this is the tenths place, this is the tenths place. So if I want to get rid of this, I'm going to have to multiply it by 100 to move that decimal over 2 places. So let's go ahead and do that. And I'm going to put this in order as well. So if I multiply this term by 100, that'll give me 25x squared. And then if I multiply negative 1.2 by 100, that's going to give me negative 120x. And then if I multiply this by 100, that's going to give me 320. Those are huge numbers. And I could have used decimals in the quadratic formula, but that sounds pretty nasty to me. These are gigantic numbers. Let's see if they have a greatest common factor, which they do. I can divide all of these at least by 5, but probably even more, but let's see if that will work. Okay, so if I divide each of these by 5, that's going to be 5x squared minus 24x plus 64. No, it looks like 5 is the biggest one that we're going to get to divide by. Okay, so A in this case, we're going to use 5. B is negative 24. And C is 64. These are larger than I like, but oh well. B squared minus 4AC. When you square B, you'll get 576 minus 4 times 5 times 64. I don't know that off the top of my head, so let's look at our calculator. So 576 minus 4 times 5 times 64 gives us negative 704. Which means, since that's negative, we're going to have two imaginary solutions. So x equals the opposite of b, so 24, plus or minus the square root of negative 704 all over 2 times a, which was 5. So this will be 24 plus or minus a perfect square that goes into negative 704 will be negative 64. You may have to play with that to find that. I would not give you this ugly of a number on a test or quiz. And that's over 10. So this is 24 plus or minus square root of negative 64 is 8i. Square root of 11. And then that's all over 10. And these are all divisible by 2. So I could do 12 plus or minus 4i square root of 11 all over 5. So you're dividing each of those terms. If you wanted to go ahead and divide it and write this as 2.4 plus or minus 0.4i square root of 11 and use decimals, I would be okay with that as well. Last example. And notice I could use A is 8, B is negative 8, and C is 2. However, I like smaller numbers, so I notice they're all divisible by 2. So let's divide both sides by 2. And so if I do that, I end up with A is 4, B is negative 4, and C equals 1. You could use the larger numbers, but you're just probably going to have to reduce radicals later on where you might get away with not having to do it at this point. You'll just have smaller numbers to work with. So B squared minus 4AC. When you square B, you get 16. Minus 4 times A times C. Oh, that's going to give me 0. Okay, so if you would use 8, negative 8, and 2, you get 0 here. So you're not going to have to do a whole lot. You'll just end up with larger numbers in your quadratic that you'll reduce a fraction, but you'll get the same answer. So x equals the opposite of b. So 4 plus or minus the square root of 0 all over 2 times 4. So that's going to be plus or minus square root of 0 is just 0. and that's over 8. Well, 4 plus 0, 4 minus 0, both give you 4. So you'll have 4 over 8, and that is going to equal 1/2 when you simplify it. So we are completed with the notes.